question. Find the number of ways to arrange all of the letters P, A, N, P, P, A, N, L, and P to form a palindrome that doesn't start with the letter N. Before attempting to solve this problem, let me first define what a palindrome is for those of you who may not know. A list of letters is considered a palindrome if it can be read the same way both forwards and backwards. For example, race car is a palindrome because it can be read race car both forwards and backwards. For this problem, a list of letters can be called palindromic if the series of letters is the same when we reverse the ordering. This leads to an observation. If we had a bunch of blanks where each blank could represent any letter of the alphabet, for a letters to be considered palindromic, the following has to happen. If the series has an odd length, or in this case 7, then these two values have to be the same, these two values have to be the same, and these two values have to be the same in order for it to be considered palindromic. Because when we reverse this series, it is the same thing as flipping these positions, but it has to be the same, so we have to make sure that each of these values are the same. If the length is even, for example here, then these two have to be the same, these two have to be the same, and these two have to be the same for it to be considered palindromic. Now let's return to the problem at hand. First, let's list out what characters are in the list. There are 4 P's, 2 A's, 2 N's, and 1 L. Looking at this list of characters, we notice that L has to be in the middle of the palindrome, because there is only one occurrence of L. If we look back at this diagram, the only possibility for there to be one of one character is when it's odd, or in this case, only in the middle, which is why we must put L in the middle. We can model the scenario like this. Let's have a series of blanks where each blank represents a letter. In this case, there are going to be 9 blanks because 4 plus 2 plus 2 plus 1 is 9. And remember, we have to put L in the middle because, as I've stated before, it is the only possibility for there to be one L and for the series of letters to be considered palindromic. Now let's look at the problem. There is a restriction that says the palindrome cannot start with the letter N. That means that both the first and last space cannot be N, because they both have to be the same character. So now that we have our situation, let's try to do some casework. Let's say that the first position is filled with P, as there are only 2 possibilities besides N and L. Let's call this case 1. Case 2 will be if we fill the first and last with the letter A. For case 1, there are 3 factorial ways for us to fill up these 3. Because the only 3 letters, we're trying to find the number of ways we can rearrange the 3 letters P, A, and N, or all permutations, which in this case is just simply the length factorial. The reason we are able to do this is because the ordering of P, A, and N for these 3 will determine the ordering of these 3 automatically. Because as we have mentioned before, these 3 have to be the same as these 3 over here. So we only have to find the number of permutations for P, A, and N, which is equal to 3 factorial, or 6. For case 2, it's a bit tricky because we're trying to find the number of orderings for P, P, and N. Notice how there are 2 occurrences of P. This means that we cannot use a simple permutation, but rather we have to use 3 factorial and divide by 2 factorial because there are 2 occurrences of P. In that case, that leads to 3 possible ways, or in this case, unique permutations of P, P, and N. And when we add these 2, we get 6 plus 3, which is equal to 9.